You are watching GrassRoots Community Television, helping you make television people watch everywhere. Broadcasting on cable channel 82 in Glenwood Springs and Carbondale, and channel 12 in Aspen, Snowmass, Basalt, and Elgin. Free over-the-air broadcasts throughout the Roaring Fork Valley. All programs can be watched anytime, anywhere at grassrootstv.org. You are watching GrassRoots Community Television, helping you make television people watch everywhere. Broadcasting on cable channel 82 in Glenwood Springs and Carbondale, and channel 12 in Aspen, Snowmass, Basalt, and Elgin. Free over-the-air broadcasts throughout the Roaring Fork Valley. All programs can be watched anytime, anywhere at grassrootstv.org.
Well, thanks everybody for coming out to what's the last Naturalist Nights of 2012. And I guess I just wanted to start by thanking all of you and some folks who aren't here for everybody who came to the series. I think we had a really successful series with really good turnout, a bunch of great speakers. And one of the really cool things we did this year is we taped 10 out of the 13 programs using GrassRoots TV. And so all the programs, or almost all the programs you see, are available on our website afterwards. And we did that in large part thanks to all of our sponsors, the St. Moritz Lodge, the Days Inn, Ken Ransford, attorney, Harry Teague Architects, the Aspen Skiing Company, Reese Henry & Co., Gorsuch, Finbar's Pub up in Aspen, Alpine Bank, Two Leaves in a Bud, Carol Dopkin Realty, Sterling Homes, and the Ute Mountaineer. So it's a bunch of sponsors, but it really makes us able to bring in some speakers from around the state and even in neighboring states and record all the presentations. So a couple of things before we get started. This is the last Naturalist Nights, but there's one more event that the workshop is hosting this spring, and that's the Backcountry Film Festival, which is put on by Winter Wildlands, and we're co-hosting that with the Colorado Mountain Club. That'll be here at 7 o'clock next Monday, the 9th. And the other thing I'll let you know about is that you probably have all noticed that spring is a little bit early this year. And the Wilderness Workshop has a restoration program. We were planning on doing some plantings about the end of the month, but everything's ready to go now. So I think I saw Mark Lacey in the audience with the Forest Service. He's helping us out, and so this coming Saturday and then the next 2 Wednesdays we'll be transplanting some spruce and planting some willow on some old road beds in the old Avalanche campground and restoring some riparian habitat up the Crystal Valley. So if you're interested, find me after the talk. So as folks probably know, this is a series put on by Wilderness Workshop, ACES, and the Roaring Fork Audubon Society. This talk is also, we're partnering with the Roaring Fork Conservancy because it's about water and stream habitat. In the back there's some hummingbird feeders and information from the Roaring Fork Audubon, so check that out. And then I'll introduce our speaker tonight, Dee Malone. Dee is with the Colorado National Heritage Program. She lives in the Crystal Valley. And she was one of the folks who spent a bunch of time working on the stream assessment program, which informed the Roaring Fork Conservancy's watershed report. So she's doing a bunch of good work, and she'll teach us about dippers tonight.
Okay, thank you, Will.
Sure thing. And if folks can just sign this, even if you've already are on our mailing list, to let us know how many folks came out tonight.
Well, thank you all for being here. I appreciate your being here, and I hope that we can learn a little bit more about dippers and primarily more about the river and the river habitats, especially in the Roaring Fork watershed. So I'm Dee Malone. I work as an ecologist with Colorado's Natural Heritage Program, And our job around the state of Colorado is to go and identify and assess and ultimately conserve our natural resources, rare plants, rare animals, rare communities, for everybody to inherit, just as they do their cultural heritage. So I entitled this Through the Eyes of a Dipper, because dippers are really unique among songbirds in that they take in and they look at a river and they're able to integrate a number of characteristics in a stream to determine whether or not that stream is suitable for them. It just so happens that those same characteristics that they need to survive are the characteristics that make healthy rivers. So what we're going to do, before I even start, I need to really thank Robin Henry. Most of the photographs, the bird photographs in here, the dipper photographs, are done by Robin. Habitat shots are typically mine, but he is such a wonderful photographer, and he let me use his photographs for tonight's talk. So what I want to do is first kind of tell you that what we're going to do first is look at dipper natural history. Then we're going to look at the characteristics of a healthy stream. And then we'll put the two together and say why, and explore why dippers are good indicators of healthy mountain streams. And then finally, we'll look at an impact that they've not yet or just are experiencing, climate change, and what our changing climate may and how it may impact dipper survivability. So, dippers are habitat specialists. There are only aquatic songbird, and dippers only occur in healthy, fast-flowing mountain streams. And in concert with that, they only occur where there's healthy riparian habitat. Riparian habitat is really essential to healthy mountain streams. They're not separate. They really work together. If you don't have healthy riparian habitat, you're not going to have healthy streams. And if you don't have healthy, functioning streams, you're not going to have healthy riparian habitat. Dippers need both. And they have adapted their behaviors, their morphology, their form, the way they look, the way their feathers are, as well as their physiology to enable their life as an aquatic songbird. So, first thing you need to start talking about when you're talking about natural history, what a bird does, what animals do, where they live, and so on, is to look at what they eat and where they eat it. So, they get their food from fast-flowing water, and the water can be really cold. If any of you, I'm sure, have gone out and seen dippers, there's ice on the stream, and these little guys are still diving in the water, getting their bugs. They eat mostly aquatic insects, and I didn't put it here, we'll talk about it a little later, but a very specific suite of aquatic insects, not just any old aquatic insects. They're very particular about what they eat. Sometimes they'll eat small fish, fish, eggs, flying insects, and beetles if they're really hungry and if their territories are really depauperate. This is a photograph of caddisflies. And that is one of the main insects that dippers focus on. And these little guys, the way they get them is they dive, they walk, and they swim on the stream bottom. And then they poke around underneath the water, gleaning, just like an aerial bird gleans for insects on leaves. They glean for insects on rocks, and they swim to catch fish. They usually stay down for maybe 15 to 30 seconds underwater. And they can do this in really cold water. So also, when we're talking about natural history, we need to talk about the phenology. So phenology is simply the course of one's life's events, how things proceed. You know, as humans, we start breeding when we're, 18, 20, 25, whatever. We get to middle age, some of us, some not. We get to middle age, and then we senesce, and we go into old age. So the phenology is just the unfolding of your life's events. Breeding is especially important because that's how you maintain a population. That's how you live in perpetuity. So successful breeding is really crucial. Onset of breeding typically from March to May. And that onset is timed with stream de-icing and with spring runoff. And that's a really important point to remember for later on when we talk a little bit about climate change. Because that timing of spring runoff is crucial to their success. So the idea is that they've actually already set up territories. This is what, April? And most, they've already established their pair bonds. They've constructed their nests already this year. And hopefully they've mated, they're starting to lay eggs right now. And they need to incubate those eggs. Those eggs need to hatch. They need to fledge those young and get those young self-sufficient before spring runoff, before the high flows. Because if high flows, so in our neck of the woods, high flows come in June. And so these young need to be out of the nest and fairly self-sufficient by the time spring flooding flows come. About 40% of the birds, the dippers in Colorado, do a second nesting after the spring flooding flows recede. So they are capable of some compensation for breeding. But that's a pretty critical sort of concept. They time their breeding with spring runoff. And afterwards, it's sort of hard to tell with dippers who's the young and who's the old because they grow really quickly. They grow much more rapidly than most other songbirds. And so the little guy on the left is the juvenile. The one on the right is the adult, still feeding. So they remain with their parents for a month and a half or so. And they're learning what to do. It's a little, life in the aquatic realm is a little more difficult. And so they're having to learn quite a bit. Okay, we're going to do some high-tech stuff here. Communication. So streams are really noisy. And how do you communicate with your young? How do you warn them of predators? How do you mate? You know, because basically your song is a mating attraction. How does that all happen in such a noisy environment? Well, they do more than just vocalize to communicate. There's some, not everybody is agreed on this, not everybody is settled on this, but dipping, that's why they're called dippers, is thought to be a way of communication. It may not be, but it certainly seems like it's a major mode of communication for them. When predators come, their dipping rate increases. When they're trying to, when young are out in the stream and they're a little bit stressed, they dip faster. I mean, they sort of dip all the time, but more slowly. And as things change, the dipping rate increases or decreases. They have white feathered eyelids. And with those white feathered eyelids, they can communicate in sort of a Morse code with their mates or with their young and back and forth. And then their song and their call. The frequency of the song is much different than the frequency of the noise of the stream. So this is my low-tech solution to giving an example of a song here. Let's see. Just bear with me for just a minute. Let's see here. Oh, thank you, Will. Okay. Oh, perfect. Maybe. Okay, that's good. I can do this.
Ruby-crowned kinglet.
Nope.
American dipper.
There we go.
crown.
Okay. So the idea is that their frequency is much higher than the frequency of the stream. So even though the stream is really noisy, that frequency enables their song to be heard by their mates or by the juveniles and so on. And John Muir was really enthralled by dippers, and he gives kind of a really poetic description of dippers in their song and how they intertwine their song with the music of the stream. In a general way, his music is that of the streams, refined and spiritualized. The deep booming notes of the falls are in it, the thrills of rapids, the gurgling of margin eddies, the low whispering of level reaches, and the sweet tinkle of separate drops oozing from the ends of mosses and falling into tranquil pools. So they have, to enable their underwater foraging, they have some pretty unique little adaptations that they've evolved, including nasal flaps that come down so that water doesn't go up their nose when they go under. They have really dense feathering, and they waterproof their feathers with a lot of preening. They have special oil glands, and they use that oil, dip it in their, under there, and they beak, and then they preen, and that waterproofs their feathers. They have really dense feathers. Other passerines, 3,000 feathers. Dipper, about 4,200 feathers. So they're really dense. They're small body and short wings. If you go out on the stream and you look at these little guys, they're compact. Well, that's really good for swimming. It may not be good for long-distance migration, but it's great for swimming underwater, particularly when they're swimming in rapids and really fast streams. They have really large, strong feet and claws, better to grip the cobbles with because they literally walk along the stream bottom, and you've got this really rushing mountain stream you got to grip on. Their eyes have two things. One, there's a sphincter muscle in their eye that allows them to tighten their eye so that their vision accommodates the lens that the water creates, so that their vision underwater is really clear. Plus, they have this nictitating membrane that comes down and acts as sort of goggles over their eyes so that they can see. And because water can be, and hopefully is, really cold, but also if it's really cold, it's well oxygenated, which is the good part about cold water. They have a really low metabolic rate and high oxygen capacity. The high oxygen capacity comes with a really high hemoglobin count. So their blood is really thick, a lot of red cells. So nest building. Where in the world do you put your nest? Well, it's a major factor when dippers are looking for territory. Stream banks are really great as long as the stream banks are stable. Under tree roots, so if you're looking at a really well-vegetated stream bank, you'll notice that there's a lot of big roots that are coming down. Frequently, they'll tuck their nest up under a stream bank or under a tree root or under a downed log. On boulders, particularly on cliffs. And waterfalls are under the one great thing that humans have done, sort of to compensate for a few other not so good things, is that we've built bridges over streams. And dippers often use those bridge abutments for nest building. The way they build their nest is sort of from the inside out. They get in, and the inside of their nest is primarily usually grasses, but also there could be some twigs and bark and so on. But they sort of stand in there, and they kind of push the bark and the grasses around them to make sort of a dome. And then they come on the outside, and they keep the outside covered with mosses. So the mosses absorb moisture from the spray from the stream, and it doesn't go on the inside. So the inside of the nest is nice and dry, whereas the outside of the nest is typically fairly moist. It's kind of a nice little behavioral adaptation for life in the stream. Okay, nest site selection. This isn't a great photograph, but it's a cool one because there's 3 dipper nests that you can see right on that cliff. And this is on the Frying Pan River, not too far up from Basalt. So there's a nest here, here, and here. So when dippers move up into their breeding territory, during winter, when the river freezes over, they move down to where there's no ice, so they can still forage. But as the ice opens up and as the river starts to open up, they start moving up. And they base their territory, determine their territory based on the potential for nest sites. On the other hand, nest sites are often reused for many, many, many years. There was a nest in the United Kingdom that's been monitored for 123 years. And dippers have reused that nest every year for 123 years. So they do come back. But the primary thing they're looking for when they're selecting their territory is the suitability of the nest site. So it has to be close to water. Good thing, because they spend most of their time foraging in water for food. Inaccessible to predators. Predators for nestlings would be rodents, weasels, squirrels, raccoons. So they're really looking for a place on a cliff or like that that's inaccessible to predators. Sufficient food supply, critical, because they've got to feed a whole bunch of nestlings. It's hard enough to feed themselves, but if you don't have enough food for your nestlings, then that year's success is compromised. Protected from flood. So this is the frying pan. The frying pan doesn't have that much fluctuation in flows, but just in case they're well up. And a natural flow regime. So those are the things that they're looking for. Now they're not going to be able to tell whether there's a natural flow regime or not, but they will focus in on things that a natural flow regime produces. And things like pools and riffles and large woody debris in the stream and boulders. So the outcome of a natural flow regime, sufficient water in the stream throughout the year, the outcome of that natural flow regime is what dippers are focusing on. And I guess I said that at the bottom. So nest site characteristics correspond with characteristics of a healthy stream and riparian habitat. If there's too much pollutant in the stream, if there's too much sediment in the stream, the food supply that they're focusing in on is going to be compromised. If there's not a natural flow regime, in other words, with spring flooding flows that overbank out into the riparian zone, the trees are going to start to die, and because if you don't have good vegetation on the riparian banks, the banks are going to start to erode, and they're going to start to produce sediment, and that sediment is going to basically kill the food supply that they're focused on. So you've got to have that natural flow regime, and the other thing about a natural flow regime is that if the stream can get out of its banks and replenish the shallow groundwater, then later on in the season, that water that's in the riparian soils will sort of be squeezed out and returned back to the stream, and it will maintain stream flows throughout the year, so that low flows during the stream doesn't dry up during the summer, so that low flows will be maintained at a sustainable level. So all of those things are kind of come together when a dipper is looking for their territory. They're focusing on food supply, appropriate nest, and those things that they're focusing on, those factors, are only going to be there if the stream is healthy and if the riparian zone is healthy. Yes?
Nests that close together?
Are
these older nests?
I think they're older nests. They've come back and they've rebuilt every year, and that those are older nests. Thank you for pointing that out. It was a good question. Okay, so what makes a healthy stream? Fast-moving, clear, unpolluted water. Structurally complex. So in this is Maroon Creek above the campgrounds. So this is structurally complex. I mean that there's riffles and there's pools. So it's not just all a single kind of stream. different things happen in those areas. Nutrients get broken down in the pools, they get released, and they come out to the riffles, and then in the riffles, those nutrients are taken up by the bugs that the dippers are focusing on. So structural complexity in a stream isn't just to make it pretty, although it really is. It also is very functional in that it provides a food resource for the dippers. Boulders and large woody debris in the water column. So in other words, dippers need a place to perch while they're standing around looking for their food. So there has to be, they could perch here on the banks. There should be in-stream diversity. So a stream that's a straight channel without any diversity is not going to supply habitat for dippers. It's also not going to be a healthy stream. It's going to be a simplified stream that's not going to produce for aquatic species like trout. There has to be sufficient water quantity. This is Castle Creek in the spring. It's probably Castle Creek, probably around, June, I think. So a natural abundance of water with a minimal amount of substrate exposed. So substrate, just the stream bottom. If the substrate is exposed, the invertebrates dry out. There's no food for the dippers. So it's important here in a natural flow regime, I say again, because it's important that those flooding flows get out of their banks, and all of this gorgeous, lush riparian vegetation is fed by the water as well as the nutrients that are in those flooding flows. So it's important that that water get out, and then later on, that water returns to the stream to maintain stream flows in the late season. So basically, provides the importance, that's the importance to the stream, to the dipper. It provides and maintains dipper foraging habitat and food resources. Water quality. This is Maroon Creek. A low sediment load. Sediment, just material, soils that come in from eroding banks, could come in from the roads, could come from anywhere. The problem with sediment is that it smothers the aquatic invertebrates that dippers are foraging on. Unpolluted. Most of the aquatic invertebrates that dippers are foraging on are very sensitive to any sort of pollution, including chemical pollution. Cold temperatures. Cold water holds more oxygen. More oxygen feeds the invertebrates. And a low nutrient load. Why a low nutrient load? Because if you get a lot of nutrients in the stream, you get a lot of algae. If you get algae, it's not the algae per se that's the problem. When the algae die, they break down, and in that breakdown process, bacteria are involved in the breakdown process, and bacteria suck up oxygen. So they essentially deoxygenate the stream. The bottom line is that successful dipper populations cannot occur if stream conditions are not suitable for invertebrate survival. So they're one and the other. And the only way that invertebrates can survive, the kind that dippers feed on, the only way they can survive is if there's healthy riparian as well as healthy stream habitat. So healthy riparian habitat. This is Grizzly Creek, just a couple weeks ago. So what does healthy riparian habitat do for the stream? Well, it filters pollutants from upland runoff, in other words, from roads, from housing developments, and so on, so that all the pollutants that we spew out, instead of running into the stream, the riparian vegetation and soils trap that and transform it. You remove that riparian vegetation, and those pollutants go straight into the stream. And stream bank vegetation actually slows the flow down. It dissipates all the energy of the stream so that you don't get so much erosive power going downstream. And you start getting pools and riffles, and you get more complex structure in that stream where foraging can occur and nutrients can be broken down in the pools. Importance to dippers. This little guy was foraging along here, and right in among this thick root system that's holding the bank together, would be an ideal place for him to locate a nest. And the vegetation, the riparian vegetation around the stream in a very practical way, when the leaves fall into the stream, that is the base of the food chain for the invertebrates. So just some very practical reasons regarding the importance of riparian vegetation. So, because dippers take a number of different environmental factors and put those all together to determine whether or not the stream is, or the habitat is suitable and is going to enable successful reproduction and breeding, they are able to tell us about if or if not a stream is healthy. So the same characteristics that they're focusing on are the characteristics that will tell us whether or not we have a healthy stream. So just to sort of look at it in a different direction, what are sites that limit dippers? So why wouldn't a dipper be present? If there's no suitable nest sites, they wouldn't be present. If the foraging habitat is somehow compromised, if there's no boulders, there's no perches, if there's no riffles, if it's all just one big flat run of a stream, that's going to not enable dippers to be there. Food abundance and availability. So dippers don't just focus in on any old invertebrate. They don't really like, for instance, mosquito larvae. Dippers really like the best mayflies and caddisflies. So this is a little mayfly here, there's one here, and there's one right there. And this is actually a caddisfly inside his gravel case. So we've got actually both inside of that picture. So some caddisflies make their cases out of sticks, others make their cases out of stones, others make their cases out of leaves. This species just happens to be the species that uses stones to make their cases. So both mayflies and caddisflies live in cobbles. They don't tolerate chemical pollution, for instance, from road runoff. They don't tolerate thermal pollution. So I didn't mention it before, but now's a good time. The canopy, riparian tree canopy, is also really important for shading the stream and keeping the temperatures really low. These little invertebrates don't tolerate thermal pollution. By thermal pollution, I just mean rising in temperature. Most of them don't tolerate anything above 20 degrees centigrade. So they really like cold water. Cold water holds more oxygen. That's an important feature as well. And they're sensitive to sediment pollution from banks eroding. If banks are devegetated and there's nothing to hold onto the soils, those soils run off, they get into the stream, and they smother these little guys, primarily because they're feeding with sort of a really fine feathery net. And if the sediment is there, it will clog their feeding mechanisms. So they can't tolerate the sediment. And they're sensitive to low pH, so acidity. We don't really have an acidity problem around here because most of our water is fairly well buffered because of the surrounding geology. But up Meeker and Craig and up in there, where you're getting some fallout from coal plants and so on, and down in the southern part of Colorado, where there's fallout from coal-fired plants down in New Mexico, there's a problem with acidity in the streams down there. Okay, so what threatens dipper survivability and what threatens their reproductive success? Well, I think water quality degradation is right up there. The degradation of the water, whether it's by sediment or chemical pollution or thermal pollution, alters the food web and the composition, and instead of having mayflies and caddisflies, you get things like mosquito larvae, and they don't eat mosquito larvae, they don't like them. Altered flows eliminates or damages habitat. So a couple pictures here. This is a picture of the Roaring Fork River, about 3 miles below the takeout, the diversion at Lost Man. So they take a lot of water out of Lost Man, and they ship it over to the Front Range. And even 3 miles below the diversion, the stream is still severely dewatered. And it was kind of, this is sort of anecdotal, but when we were conducting the stream habitat assessment, I visited this section of stream prior to their time when they could start taking out. And there was water in it, but there weren't any dippers. And I couldn't understand it. Because normally in a good, healthy stream, and in here I would see dippers. There should be dippers. So I started turning over the rocks. There weren't any bugs. Why in the world aren't there any bugs? So I thought about it, but I went on. I thought about it and thought about it. Well, I went back, I don't know, a month or two later, and lo and behold, they'd turned on the diversion. And the stream was totally dewatered, and there was no bug recruitment. There was no survivor, or very little survivorship of the invertebrates in there. So dippers just didn't select it. They said, this doesn't work. We're not going here. Over here, if you can see, between these cobbles, the cobbles are all filled with sediment. And bugs can't live under that sediment. It's literally smothering them. The last one here, this last photo over here is on the upper frying pan. And it kind of takes into a couple of these things. They've straightened the stream. On the roadside, riparian vegetation is removed. The stream structure has been simplified. There's no pools, there's no riffles, it's all just one run. There's really nothing for the dipper to perch on. There's no large woody debris, there's no boulders, there's no riffles. There's really no foraging habitat. There may be bugs there, but there's no way for the dipper to get those bugs. Additionally, the flow regime in the frying pan is altered because of the dam. And so we don't have a natural flow regime. We don't have sufficient overbanking to maintain riparian vegetation. Okay, now the big bad guy. Climate change. So just a couple of brief things. And if anybody's interested, I have a slide with lots of references that you can all look up afterwards. Temperature. Colorado climate is warming by the mid-2050s according to an A2 emission scenario. So that's kind of an average if we stay in our what we're doing now. If we don't change what we're doing now with our lifestyle, the emissions stay the same. That's an A2 emission scenario. By the mid-2050s in Colorado, temperatures are projected to increase annually by approximately 5.5 to 5.9 degrees Fahrenheit. In that same emission scenario, precipitation is projected to decline from 3 to 7%, although not every season of the year. Precipitation is projected to decline in the spring, in the summer, and the fall. It's projected to increase during winter. But overall, the overall projection is for a decline. Additionally, what we'll see in winter is more precipitation falling as rain. One of the important things about our snowpack is that it's essentially a big storage feature. It releases the snow as it melts slowly. There'll be less snow held in storage because it'll come as precipitation. And there'll be an earlier snowmelt. In fact, we're already starting to see average 30 to 40 days earlier for spring floods in the west. And the stream flows will be reduced. I didn't put a number up there to it because depending on which warming scenario you believe, reduced stream flows will be reduced by different percentages, but regardless of which scenario you look at, stream flows will be reduced. Up here, because of an increase in temperature, there's lots of things that happen. Soils get warm, which leads to drought. Warming soils results in increased evapotranspiration, so transpiration by plants for warming. So everything gets droughty and everything gets drier, and stream flows decrease. I have these two pictures up here. This is but they're both the Roaring Fork. This is the diversion at Lost Man that takes the water over in the tunnel. This is just below the diversion. And this is just above the diversion. Both of these were in probably September or so. So above the diversion, this is low flow time of year. There's plenty of water in the stream. Below the diversion, there's this. One of the things that will definitely happen with decreased precipitation and decreased stream flows is that more of our water will go over to the Front Range because their warming is predicted to be even greater than ours. So, what are these impacts for the dipper? Well, probably the most important thing to look at is that their phenology is closely timed with spring flooding flows. And the question is, can they adapt to earlier spring floods? Remember I said that they nest and they get their young out and they fledge their young and get them independent before it floods in June. If that's moved up by, say, a month or a month and a half, can dippers change their timing of breeding sufficiently to accommodate for that? Maybe. There's still a lot known about whether or not species will be able to compensate for these phenological mismatch. So there's a mismatch in the timing. What we've been doing at the Heritage Program is we've been examining numerous plant and animal species as well as bugs and looking at their sensitivity to climate change. So these are a few of the things that we look at to evaluate whether or not a species is vulnerable and whether or not they're going to be able to, or how likely they are going to be able to survive a changing climate. So we look at impact of land use changes resulting from human responses to climate change. That simply means one response to a changing climate and drying is to build dams because we want to store that water, or to build wind generation. If we build wind generation in a flight path, a migratory flight path for birds, that's going to have a negative impact. Or are we going to put a solar array in the desert where there's threatened plant species? So those are great energy alternatives, but I think they need to be closely looked at with regard to their impact because they can have negative impacts also. So that's what that first question has to do with. So if we put a dam or a hydroelectric generator that dries up a stream so that we can get off of coal use, so we're going to use hydroelectric instead. Yes, it's clean energy, but it's also going to dry up the stream, and everything in it is going to be impacted by that. Another thing we look at is sensitivity to changes in temperature and precipitation. Dippers may not be sensitive to precipitation and temperature per se, but they're sensitive to the changes wrought by increased temperature and decreased precipitation, namely less stream flows. We also look at dependence on a disturbance regime that would be likely to be impacted by climate change. So a disturbance regime could be, for instance, fire. We have a natural disturbance regime in the West. What's going to happen? Is that going to impact the dipper? Fire, likely not. Other species, yes. A natural disturbance regime is spring flood. Is that disturbance regime likely to be impacted by climate change? Yes. Is it likely to impact the dipper? Yes, absolutely. Dietary versatility. They have very little versatility in their diet. They really focus on caddisflies and mayflies. And if caddisflies and mayflies are not there in the stream channel in a sufficient abundance, dippers are absent. But on the other hand, where there's a sufficient abundance of caddisflies and mayflies, they are always there. So they have very little dietary versatility. And the phenological response to changing temperature and precipitation. That simply means, are they going to be able to adjust their breeding time to a change, to a documented change in the time of spring flooding flows. The result is that, or the result of the analysis is that dippers are highly sensitive to the impacts of climate change. So management. Management that protects riparian areas from overgrazing. Basically, management that ensures functioning riparian habitat and functioning stream habitat will also protect the dipper. The interesting thing is that, yes, climate change is upon us. Yes, there will be impacts. But if we can restore habitats to functionality, if we can restore riparian habitats, and we can restore stream habitats to functioning stream and riparian habitats, we can moderate the impacts of climate change, I strongly believe. In other words, if riparian vegetation is intact and stream banks can get out of their, stream flows can get out of their banks, water can be stored naturally to replenish those streams during low flows. In the upland habitats, if the shrublands are healthy and the forests are healthy and intact, those soils will also store water. Those trees will ameliorate warming. So it's an interesting dilemma. We've created some habitat alteration, and we're creating a changing climate. But I strongly believe that if we can restore natural habitats and restore functionality to those natural habitats, we can moderate the effects of climate change, and we can alter the demise, the headlong demise of a lot of our native plant and animal species. And I have that last little thing in there, protect existing nest sites. Nest sites are difficult to find. They had all of those parameters that they had to meet. They have to be, above floods. They have to be inaccessible to predators. They have to be in the right site. So dippers reuse those nest sites. And so we need to really, one strategy to preserve dippers and also protect functioning streams is to protect existing nest sites. So that fella that's been coming back or his offspring that have been coming back for 123 years, they can continue to find that nest when they return. Okay, and finally, thank you. Roaring Fork Audubon, Roaring Fork Conservancy, Wilderness Workshop, ACES, and I want to say this has been a great collaboration of all of the conservation organizations in the valley to bring these talks together, and I think we've had a really great result. And finally, again, I want to thank Robin Henry for his just absolutely fabulous photographs. Thank you. Does anybody have any questions? Jan?
Well, I have a couple questions. How deep can dippers go in the stream?
The streams, mountain streams, aren't they really that deep? Oh, the question was, how deep can dippers go when they're diving in a stream? And the first part of the answer is that typically mountain streams really typically aren't that deep, just really, even at high flows, a couple of meters. So probably like 1.5 to 2 meters.
And then in a year like this year, I read that on the Yampa River, it's already had its peak flow.
Mm-hmm.
So now could the dippers nest after the peak flow?
It's a question that we don't really know. I mentioned that about 40% of the dippers in Colorado have a second nesting. So they wait until after the spring flow, and then they nest afterwards. So it's an area that really needs to be studied. So the answer is I don't know. If they could, it would certainly help their survivability. Yeah. Kendall.
A lot of fishermen call dippers, many fishermen call the dippers water ouzels.
Mm-hmm.
So I was wondering if you knew where that name came from. That's what a fisherman asked me today.
You know, Kendall, I have no idea. Does anybody know?
Yes,
Linda?
it's what they call them in England or in Europe.
Okay.
Water ouzels? Does it mean anything?
Well, it means the same as dipper.
Okay. Does anyone else have any questions? Linda?
I have a comment.
Okay.
I don't think I've ever told you that I had dipper nest boxes up. And I had dippers nesting on the Roaring Fork before a flood wiped out the box. But I have them from time to time at Difficult on a nest box, in a nest box.
That's fabulous. I would love to see those because, yes, you can put up nest boxes for dippers, and they've done well. So that, I would love to see those, Linda.
Yeah. I'm thinking about the site where the bypass is to on Independence Pass to send water to Denver. If they had a minimum stream flow requirement below the diversion, would that increase the likelihood that the caddisflies and mayflies could survive, and thus the dippers survive up there?
That is their minimum. They do have a minimum stream flow.
Oh, that is dry? Okay.
Yeah, but the answer to the second part is yes, absolutely. Because I would say for at least 3 miles below, and that's a goodly stretch of stream. The photograph that I showed was at 3 miles, and some water from side drainages and from just groundwater just barely starts getting the flow going again. So absolutely, minimum flows would definitely make a huge difference. Yeah.
Give you the mic
Do
back
we
here.
know what the lifespan is?
Yes, ma'am.
Do you have any data about the presence of dippers in the Crystal River?
I do. Just off the top of my head, the Crystal River below Marble is very depauperate. Primarily, you've got, and the habitat, the dipper habitat is poor. Primarily, well, I'd say primarily, there's several reasons. One, you've got the road cut going along most of it. You've got the highway. And that highway has eliminated a lot of riparian vegetation. And along with that, you've got a tremendous sediment load coming in from the sides, from the banks, because they've removed the riparian vegetation. And you've got a huge sediment load coming in from Coal Creek, which is right in Redstone. So that is, and just as a matter of interest, the Roaring Fork Conservancy is actively working to do some mitigation up in Coal Creek for just that very reason. So you've got sediment problems, you've got stream straightening problems, because when they put that road in, they changed the natural shape of the stream so that they've eliminated a lot of the natural meanders and the natural flows that would create pools and riffles. That being said, it's restorable with really some fairly low-tech restoration. There are large stretches of the crystal that could be restored to functionality. Yeah.
No, I just wanted to know the lifespan of a dipper. Maybe that's a stupid question.
No, it's a great question. The question was, what is the lifespan of the dipper?
Yeah.
Well, if they make it past being a juvenile, which is always a difficult stage, probably less than half of the juveniles survive to adulthood, then maybe 5 to 7 years. And it really is, it's highly dependent though, but once you get to be an adult, things are looking up.
Yeah. We know that.
dippers don't migrate. I mean, they pretty much stay in the same area the whole time.
They migrate elevationally. So as the stream freezes, they move downstream and to an area that's open because they're just basically looking to be able to forage. As the stream opens up, as the ice opens up, then they just move back upstream. Janice?
Maybe I missed this a while ago when you were talking about that, but years ago when you first started that study and you were looking at the stream flow below that diversion and how it was so dry, didn't they talk about that a lot and they were going to fix that or change that or have a higher flow so that that situation changed? Did nothing ever happen?
They did provide a few more CFS. Off the top of my head, I don't know the number. It's not sufficient.
Not enough for the invertebrates.
But they did actually provide the Roaring Fork with a few more CFS.
Guess they need to keep working on it.
Indeed.
One more. Maybe we'll take one more question, and then I'm sure Dee will stick around afterwards.
Absolutely.
I had read that a male dipper that has a very excellent habitat may have a female at one end and another female at the other end. Is that valid?
True story. It really depends on food supply. So if he's got an abundance of food, then there is sufficient food to supply all the nestlings. Then and because they both, male and female, participate in feeding the young, then he can have a couple. Yeah, true.
Who builds the nest?
She does.
She does.
Thanks, Dee, so much.
You're welcome.
And I'll just remind folks that if you want to help restore some dipper habitat, you can come out this Saturday or any of the next following 2 Wednesdays along the Crystal. So Thanks, Dee.
All right, you're welcome. Thank you. Thanks, everybody.